Hello everyone, welcome to another video of PyNet Labs. My name is Chirag Dhal and I welcome you all in this video. In this video, we are going to discuss about the solution of assignment number 7, which was posted on the Telegram group of PyNet Labs. These assignments are part of $100 giveaway. So if you too want to participate in such giveaways, you can make sure you join the group from the link given in the description. So let's quickly get started and let's see what do we have to do in this assignment number 7. So this is our assignment number 7. It asks you to design the topology as shown below and configure the devices in order to fulfill the requirements given in the task. So the first requirement here is assigning IP addresses from the network 200.10.1.0 depending upon the requirements for route number 1, route number 2 and route number 3. Then between route 1, 2 and 3 we have to use a /30 network. So first of all, basically the question is asking you to perform VLSM and configure the IP addresses on the devices.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So I have a similar type of topology ready here in the packet tracer. Let's begin the configurational part. So I'll open the assignment again. It asked me that create the subnet for LAN connected to R1 and R2 to fulfill the requirement of 60 hosts in each of them. So we have a requirement of 60 hosts here. Then we have a requirement of 60 hosts here. And then we have a requirement of 30 hosts here. So we have to calculate the subnets according to these requirements. So for a requirement of 60 hosts, I can simply use a /26 network. So 200.10.1.0/26 can be used here for the requirement of 60 hosts, which will include around 64 addresses. Then the next requirement is again of 60, then we have for 30. The next network ID will be 200.10.1.64/26. Then after this point, the next network ID should be 200.10.1.128 with a /27 subnet mask because the requirement here is reduced to 30 hosts. Then after this, we will be having some /30 subnet between these two routers and these two routers. Now the range here will be ending at 159, right? So we will have a network of 200.10.1.160/30 here between router number 1 and router number 2, and 200.10.1.164/30 between router number 2 and router number 3. So these are going to be the networks which I am required to configure on these interfaces of the routers and the devices connected. So let's begin the configurations now. I'll go to this router number 1. Inside the CLI, I'll start putting the IP addresses. So say enable config t. I'll change the host name to PyNet 1. Then I'll go to interface FA00. We'll say IP address 200.10.1.1 255.255.255. For a /26 we can use 192 and say no shutdown. On interface FA0/1, I'll put the IP address as 200.10.1.161 255.255.255.252 and no shutdown. Then I'll go to router number 2 and we'll start putting the IP addresses there. I'll go to the CLI, say no, enable config t, host name PyNet 2. On interface FA00, we will have the IP address as 200.10.1.162 255.255.255.252 because the subnet mask we are using here is of /30. Then I'll say no shutdown. On interface FA1/0, we will have the IP address as 200.10.1.65 and the subnet mask will be 255.255.255.192. then say no shutdown. Then finally on interface FA0/1 we will put the IP address from the network 200.10.1.164. so IP address 200.10.1.165 255.255.255.252 and say no shutdown. Exit. Now I'll go to router number 3 inside the CLI, say no, enable config t hostname PyNet 3 on interface FA0/0. I'll have the IP address as 200.10.1.166 255.255.255.252. No shutdown. Then on interface FA0/1 I'll have the IP address as 200.10.1.129 with a /27 subnet, so 255.255.255.224 and say no shutdown. Exit. Then after this, let's see what do we have next to do. We are done with the task number 1. We have created the subnet for R1 and R2, then with a requirement of 68 addresses. Then we have also created the subnet for router number 3 with a requirement of 30 addresses. And lastly, we have also configured /30 networks between R1, R2 and R3. Now the next thing is to configure OSPF multi-area to make all the networks communicate with each other. So the yellow part should be area 10, the blue part should be area 0, and purple should be area 20. So on router number 1, my LAN facing interface is going to be inside area 10 and the other one will be in area 0. Similarly, in router number 3, my LAN facing interface will be inside area 20 and the other one will be in the area 0. Then all the interfaces of router number 2 is going to be in area 0. So even if I just put some figures here to make the differentiation, then this is going to be my area 0. The yellow one is going to be my area 10, this one, and then we can say the purple one will be my area 20. So let's put the OSPF configurations now so that all these networks can communicate with each other. I'll go to router number 1 and we'll say config t router OSPF 10 exit interface FA0/0 IP OSPF 10 area 10, then interface FA0/1 IP OSPF 10 area 0. After doing this, I'll take the exit here, then I'll go to router number 2, we'll put the OSPF configurations there. Here all my interfaces are going to be a part of area 0. So router OSPF 10 exit interface range FA0/0 to 1, FA1/0 IP OSPF 10 area 0 exit. Then I'll go to PyNet 3. There I'll put the OSPF configurations. Say router OSPF 10 exit interface FA0/0 IP OSPF 10 area 0 and interface FA0/1 IP OSPF 10 area 20 exit. After configuring them in the OSPF domain, we can wait for the neighborship to come up and then we will check if all the devices have the networks inside their routing table. Okay, the neighborship is not coming up. I'll just quickly see if the neighborship is there between devices or not. So yeah, we have built the neighborship with router number 1, but the neighborship is not there with router number 2. Okay, let me just quickly check if I have to do some troubleshooting. There you go. We have the neighborship built now successfully. So if I go to router number 1 and say do show IP route, then we have some OSPF routes here. We have the OSPF route for 200.10.1.64, then we have it for 1.164, which are my indirectly connected networks, right? We basically should also have it for 200.10.1.128. Let me see if we have it here on the router number 2. Okay, let's see if we have the route here. So I'll say end show IP route. When I run this command, I can see the route for the network 200.10.1.128. So let's do one thing. Let's clear the OSPF process here, or let me check it again. There. So it took some time to learn the route, but now we have the route here. So that means the OSPF configuration is successful. Now let's see what is the next task here in the assignment. We are done with this also, configuration of OSPF. Now the last task is to configure DHCP on router number 1, and we have to create the 3 pools on router number 1 only, and we have to configure DHCP relay for router 2 and router 3. So we'll be creating the 3 DHCP pools here on router number 1, and we will use DHCP relay to assign the IP addresses to the PCs connected to PyNet 2 and PyNet 3. So on PyNet 1, I'll create the pools. So IP DHCP pool A for the network 200.10.1.0 255.255.255.192. Then the default address, or we can say the default router address or the gateway address, will be 200.10.1.1. Say exit. Then I'll say IP DHCP pool B for the network 200.10.1.64 255.255.255.192, and the default router address is going to be 200.10.1.65. Then take an exit. IP DHCP pool C for the network 200.10.1.128 with a subnet mask of 255.255.255.224, and the default router address is going to be 200.10.1.129. Exit. After configuring the DHCP here on PyNet 1, we also have to put the IP helper address command on PyNet 2 and PyNet 3 so that these devices can get the IP from router number 1. I'll go to PyNet 2, I'll go inside interface FA1/0, config T interface FA1/0, and we'll put IP helper address as 200.10.1.1. Exit. Similarly, I'll go to this router number 3, which is PyNet 3. We'll go inside interface FA0/1. We'll say IP helper address 200.10.1.1. Exit. Now let's go to these PCs and put IP address on them. So when I select DHCP, it gave me some IP with the correct subnet mask and the gateway. Then I'll go to this PC1 DHCP. There you go. Then on PC2, okay, we have received the IP address successfully. Then on PC3 also, perfect. I'll go to PC4. Perfect. Then finally on PC5. There you go. Now we can also check the connectivity by pinging the first PC 200.10.1.2. So the DHCP relay is working fine. We have received the IP on all of the devices. The communication is there between devices. That means OSPF configuration is also correct, and the IP assignment is also correct, as we have already submitted the network 200.10.1.0/24 for the given requirements. So I can assume that I have completed the assignment correctly and successfully, and it's time to submit this. So I hope you guys enjoyed the video and got to learn out of it, and I'll see you in some other video. Till then, take care, keep practicing such protocols, keep practicing such labs, and bye bye.